So, in Chapter 9-4, we're going to be testing the hypothesis for proportions. So, our objectives are to test the hypothesis about a population proportion using the p-value method. We're going to then test the hypothesis about the proportion using the TI 83 and 84. Our first objective is to test the hypothesis about a proportion using the p-value method. So in looking at a first problem, we see that in a recent Gen X 2Z American College Student Survey, 90% of the female college students rated the social network site Facebook as cool. The other 10% rated it as lame. Assume that the survey was based on a sample of 500 students. A marketing executive at Facebook wants to advertise the site with the slogan, "More than 85% of the female college students think that Facebook is cool." Before launching the ad campaign, he wants to be confident that the slogan is true. Can he conclude that the proportion of female students who think Facebook is cool is greater than 0.85? This is an example of a problem called a hypothesis test about a population proportion. So just to be clear about our notation, P is the population proportion of individuals who are specified in a category or who has a particular characteristic. X is the number of individuals in the sample who are in the specified category or who has the particular characteristic. N is the sample size, and P hat is the sample population, the sample proportion of individuals who are specified in the category. So in this particular example, P hat is equal to X over N. Well, in order for us to use the hypothesis test about a population proportion using the sampling distribution, we must require that the sampling distribution be approximately normal. The following assumptions ensure this. We have a simple random sample. The population is at least 20 times as large as the sample. Sometimes we don't always know this. The item in the populations are divided into two categories. That means that one has the characteristic and the other does not. And the value of n times p and n1 minus p are both at least 10. So the p-value method is the following. First, we state the null and alternative hypothesis. That means we have an H naught where we have P is equal to P naught, and H1 is P is not equal to P naught, or P is greater than P naught, or P is less than P naught. Then we make a decision, we choose a level of significance in which we are going to reject the null hypothesis. Usually this is at 5%. Then we compute the test statistic, and here's the calculation by hand. Z is equal to P hat minus P naught divided by the square root of P naught 1 minus P naught divided by N. And then we compute the p-value, and we put it on the standard normal curve to find out how many standard deviations p hat is away from p naught, and then we calculate a p-value area. So it depends upon our alternative hypothesis. If p is less than p naught, we're looking at the left-hand side of z. If we're doing the right-tailed test where H naught is greater than P naught, we're looking at the p-value to the right of Z. And then if we have H naught not equal to P naught, we have to add the sum of the two tails for Z. Then in step 5, we interpret the p-value and make a decision. That is, we either reject or do not reject H0 if the p-value is less than or equal to the significance level of alpha. Then we state our conclusion. So going back to the previous problem where 90% of the female students rated the social network site Facebook as cool, and the survey was based on a random sample of 500, the question is, can the executive of Facebook that wants to advertise the slogan more than 85% of the female students thinks Facebook is cool, can they actually do that? So again, the proportion is 0.85 and that we're looking at, and the significance level is 0.05. So we have a simple random sample of students. So we're looking at the assumptions right at the moment. The members of the population fall in two categories. One, that Facebook is cool, and those who do not. The size of the population of female students is more than 20 times the sample size, we hope, n is greater than 500. And the proportion specified by the null hypothesis, p0 is equal to 0.85. When we use this number with n, we see that we get 425 is greater than 10. And when we actually do the opposite, the complement, times 500, we get 75 is greater than 10. So we now can use the sampling distribution for p hat to calculate our hypothesis. So we develop our null and alternative hypothesis. One is H0, p is equal to 0.85, and H1 is p is greater than 0.85. So after we've done step 1 and 2, now we check to see the test. We calculate the test statistic, and when we do that, we use the formula for the test statistic for proportions. There it is. And we take the information that we know and we plug it in to the equation. So we get 0.9. This sample proportion that we get is 0.9. And we want to test it against 0.85. So we do that. And so we also do the standard error. And we get a final result of 3.30. Now, once we look at the Z statistic, we now can try to find a p-value on the standard normal curve. And when we do that, we're looking to the area to the right of 3.13. And if we go to table A2 in our book, we see that this area is 0.0009. We've also done it using technology. We can find the area to the right under the standard normal curve, and we see that it's 8.74 times 10 to the negative fourth power, which is very close to 0.0009 when we round up. Since the p-value, and now we look at our decision rule, since the p-value is less than 0.05, we reject H0 at the 5% level and conclude that more than 85% of the female college students think that Facebook is cool. We'll now do the same problem to test the hypothesis using the TI-83 or 84. So again, we're looking at the same problem. In the American survey, we found that 90% of the female rate the social network Facebook as cool. Another 10% rated as lame. Again, we are looking at 500 students in the survey, and the marketing executive at Facebook wants to advertise that more than 85% of the female college students think that Facebook is cool. And so he wants to make sure that it's true, so he's going to do a hypothesis test. And so we'll go to the next slide. Again, as a reminder, P is the population proportion that we're going to be looking at. X is the number of individuals in the sample who, in this particular case, think that Facebook is cool. N is the sample size. In this case, N is going to be 500. And then finally, P hat is just the proportion of individuals in the sample that think that Facebook is cool. And of course, in this particular case, the number of individuals, well, we don't really know the number of individuals, but if it was 90% 500, then it would have to be 400 individuals thought it was cool and out of the 500. I believe that's correct. Maybe not. Hold on. Divided by 500. Oh, that's 0.8. This is equal to 0.8. So this doesn't work. So 90% of 500, right, is probably 4,500, but let's just check. Yes. So X in this case is equal to 4,500 divided by 500, which is equal to 0.9. So again, we have to check the assumptions about the population proportion. We have to make sure that we have a simple random sample. The population is at least 20 times as large as the sample. The item in the population are divided into two categories, in that n times p is greater than 10 and n 1 minus p are greater than 10. And now we'll go to the next slide. And so on the TI-83 or 84, we're going to use the one-prop t-test command that will perform a hypothesis test. So you will see that the screen, after you hit the stats key, you come over to test and you choose option 5. Then you will hit enter and you get a screen that looks like this for the one-prop z-test. And of course, in this particular case, we're going to let P naught be 0.85, and we calculated X earlier to be 450 because that's the 90% of individuals that thought Facebook was cool out of the 500. And then we're going to choose the alternative hypothesis. In this case, it's greater than P naught, and then we'll hit calculate. So looking at the same problem, we're going to go down to the solution, of course, and just reiterate that we have to make sure that the assumptions are true. And again, we have a simple random sample. The members of the population fall into two categories, cool and not cool. The size of the population of the female college students is probably more than 20 times the sample size of all college students. So 500 out of how many there probably is throughout the nation. The proportion specified by the null hypothesis is 0.85. And so we know that n times p is greater than 10, and n 1 minus p is greater than 10 as well. So these assumptions are satisfied, and of course the next step is to set up the hypothesis test, which we did earlier. So now we remember the basic information from our problem, and then we press the stats key, we move over to the test key and select one proportion, z-test. We then enter the information into the calculator. So the information that we had, we will enter into the calculator. And you will recall we calculated x to be 450. Why? Because it's 90% of 500 that was surveyed. Remember that P naught is 0.85. X in this case is 450. N is 500. And then we select greater than P naught and we hit the calculate key. When we hit the calculate key, we end up with the screen that is there in the center where z is equal to 3.13. We got that when we did it by hand, but it automatically, here's the beauty, is it automatically gives us a p-value, and there it is. It's 0.000008 right? Because that e to the negative 4 is telling you it's 10 raised to the negative 4th power, so you have to move over to the left 4 positions. Well, this is approximately 0.009, so when we round up to 4 decimal places, it gets to be about 0.0009. And since the p-value is less than 0.05, we reject H naught at the 5% level. If the level was different, we would be rejecting it at that different level. And conclude that more than 85% of the female students think that Facebook is cool. So it looks like the executive can now advertise that more than 85% of the female college students think that Facebook is cool. So the things you should know out of this chapter is the notation used to performing a hypothesis test about a population proportion, the assumptions for performing a hypothesis test about a population proportion, and how to perform a hypothesis test about a population proportion using the p-value method and also using the TI 83 and 84. Well, this concludes our chapter 9. We have through this chapter looked at both qualitative and quantitative variables for hypothesis testing. And now you probably should look at the videos of how to solve some of the problems in this chapter.